All right, in this section 4.4, we're going to look at graphing the other trigonometric functions. We looked at how to graph sine and cosine, so now we're going to look at tangent functions and the inverse reciprocal functions. So let's start off here with tangent function. You can see here on the left, we have a bunch of different values plugged in for tangent there, and then the result on the right. And then if you look here, we have those points kind of plotted out. I want you to notice a couple of points here that say undefined. There's a few of these in here. These are where we're going to end up getting asymptotes. So, for example, here's one at negative pi over 2. And so we're not going to be able to cross that. It's going to give us a vertical asymptote, negative pi over 2. Then there's one here at pi over 2. And in fact, if you keep looking down that chart, you're going to get one also at 3 pi over 2. And you're going to get them at basically at the half pi over 2s, but you kind of have to do every other one. So it'll be like pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on and so forth like that. You're going to get undefineds because what ends up happening in those locations is you end up having to divide by 0 because those are the places where cosine is 0 and tangent is, if you remember, sine of x divided by cosine of x. So whenever cosine is 0, we're going to get one of those asymptotes. If you look at the other place, the other point, you can see we actually get kind of a curvy looking loopy shape there. It turns out what that ultimately ends up looking like as it curves over toward but not crossing that asymptote, and then it curves back this way toward but not crossing. And so you end up with this, and it repeats between these asymptotes just like this. And if our graph went over, this would continue on up toward another asymptote. And it would do the same thing over here on this side where it would come and do something like that over there on that side. And it just keeps going like that on out to infinity in both directions. So make sure you know that basic shape right there and that you can do that one, because then you'll have to do transformations and move that around from that location. So our domain here, we're going to have all real numbers except the odd multiples of pi over 2. All right, that's everywhere cosine of x equals 0. Whenever that happens, we're not going to be able to use that value, and that's also right where our asymptotes were occurring, the odd multiples of pi over 2. So negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. The range for this is going to be everything, negative infinity to positive infinity. And you can see that in this picture. This continues on up to infinity and on down to negative infinity, so we can get any number as a result of this. The zeros, you'll notice they occur here. It's at 0, at pi, at 2 pi, and then we'd have one at 3 pi and 4 pi. And so the zeros, they occur at multiples, positive and negative multiples of pi. All right? And this is where sine of x equals 0. The symmetry, if you look at this picture, is going to be odd. It is symmetric about the origin. The period for this, how long does it take to repeat? So far, sine and cosine, they took 2 pi to repeat, but you notice this is repeating, if you look at here, is from here to here, and that's just from negative pi over 2 to pi over 2. That's a period of pi now. So it repeats every pi instead of every 2 pi like sine and cosine. And we have vertical asymptotes. That's at all the places we have to cut out of our domain. And they occur at n pi over 2, where n is 1, 3, 5, 7, 9, so on and so forth. Or I guess plus or minus n. Okay? And that's where all our asymptotes occurred, and those are the places, again, where cosine is 0. Okay, so that's the tangent function. Let's go ahead and look at its reciprocal function, the cotangent function. This is 1 over tangent, which is going to be then cosine over sine. And if you look here, it's all nice and plotted out already. You can see we're suddenly getting asymptotes that are in different positions. So before, the asymptotes were at the pi over 2's, the odd ones, and the zeros were at 0, pi, and 2 pi. Well, whenever you do the reciprocal, you're doing the reciprocal of this. Well, what's 1 over 0? That becomes our new asymptotes. So everywhere that tangent had zeros are now asymptotes because we're flipping it over and we're dividing by 0. So these now are our vertical asymptotes. And where we had the vertical asymptotes before, at your pi over 2's and 3 pi over 2's and so forth, so on and so forth, they are actually our new zeros. So when we take the reciprocal of something, all your zeros become asymptotes and your asymptotes become zeros. And so then we end up with a very similar looking graph that looks like this, though, except it's flipped around, kind of mirror imaged the other way as far as how it's curving. And it looks like that. And this, again, just like the other one, will keep going in both directions, on and on and on. So here we can look at our domain. Our domain is going to be all real numbers except multiples of pi. Because again, that's where the zeros were in the last one. And now that it's sine of x in the denominator, this is where sine of x equals 0. Okay? The range is going to be negative infinity to positive infinity. We can still get any numbers out of it. Our lines go straight up to infinity and down to negative infinity. Our zeros now are occurring at odd multiples of pi over 2. And this is where cosine of x, which is now in the numerator, cosine of x equals 0. The symmetry for this one is also still odd, so it's about the origin. We, again, just like tangent, we have a period equal to pi, where that's where we're repeating, right from there to there, and then it repeats again. And our vertical asymptotes now are occurring at n pi locations, where n is equal to plus or minus 1, 2, 3, 4, 5, 6, to basically equal to those integers. Okay, and so taking a look at this, there's one more thing. So I told you that, how do we get this graph? If you know the tangent graph, you should be able to get this one because we're just doing the reciprocal of it. So when you're doing the reciprocal, all right, your zeros go to vertical asymptotes. Your vertical asymptotes all become zeros. Wherever your graph is close to 0, it gets far from 0. And wherever your graph is far from 0, it gets close to 0. Okay? And just kind of keep that in mind as we do this. And so real quick, I'm going to not leave this here, but if I were to sketch in the tangent graph, it would look like that in this section. That's the tangent graph, and it would do this. And so you can see, here's a 0 from the tangent graph, and it became an asymptote for the reciprocal, the cotangent. Here's a 0 for the tangent graph, and it became a vertical asymptote in the reciprocal graph. And then here was a vertical asymptote for the tangent graph, and it became a 0 for the cotangent graph because it's reciprocal. And then if you notice here, tangent is close to 0, but the cotangent is far from 0. See how that happens? We get the closer our tangent graph gets to 0 over here, the further our cotangent graph gets away from 0. And then as the cotangent graph, or I'm sorry, as our tangent graph blows up and gets really far from 0, our cotangent graph gets really close to 0. So they kind of flip-flop, okay? Negatives stay negative. So here we're getting negative away from 0, and the cotangent's getting negative closer to 0. Here, tangent is close to 0, but negative. So cotangent is far from 0, but negative. Okay, so just kind of try and keep that in mind. Once you know tangent graph, you should be able to come up with the cotangent graph. So let me get rid of all that red. Leave with a nice cotangent graph, okay? And so now using those same ideas, I'd like to go ahead and graph the secant function. If you don't remember, the secant function is 1 over cosine. And so I'm going to put that in there, 1 over cosine of x. And in the last function, we were graphing the cosine of x, and it looked like this. Okay? And so anytime I need to graph the secant function, I first start by either sketching or thinking about the cosine function. So this green one is cosine of x. That's what it looks like, and we did that in the last video. And so we're going to do the same sort of thing. And in fact, I think I left off one little step in the last one. But anyway, zeros will become asymptotes. So everywhere there's a 0 on cosine, I'm going to get a vertical asymptote. So right there, right here, these zeros are going to become my vertical asymptotes. There you go, right there. Then, ones, I forgot that on the last part, but when you have whenever you have a value of a 1, it goes to 1 as well, because when you take the reciprocal of 1, you still get 1. So here we have a 1. Here we have a negative 1, the reciprocal of negative 1. So negative 1 goes to negative 1 as well. And then there is a 1 as well, and everywhere there's a 1. And then we look at this and we say, all right, right here, we're getting close to 0. So up here, we need to be getting far from 0. Getting close to 0, get far from 0. Here, we're getting close to 0 on the negative side, so we need to get far from 0 on the negative side. Close to 0 on the negative side, far from 0 on the negative side. Close to 0 on the positive side, far from 0 on the positive side. And so when we do that, and then here we're kind of medium, and so we're just going to kind of be medium far away, but we're going to be at 1, and you can connect these points because we have a whole chart of them right there, but you're going to basically get this shape. You're going to get these U shapes like this. All right, and so you could go through, and do this table like is there on the right, or you can kind of think, well, I know the cosine graph, so I can come up with the secant graph by simply following those steps. Everything big becomes small, everything small becomes big, ones stay ones, zeros become asymptotes, and asymptotes become zeros. And so that's what we end up with right here. You can ignore the green line that's in there, that green cosine graph, and only look here at the red that is the secant x graph. Okay? The domain for this, well, if you see, we can put in everything we want except pi over 2's. So all real numbers except, again, odd pi over 2's. Odd, or not odd intervals, odd value, or odd, just put pi over 2 values. So wherever we get a pi over 2, or wherever we're plugging in a pi over 2, here, 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 those were the actual zeros, and this is where cosine of x equaled 0, kind of like with the tangent function, because now cosine is again in the denominator. The range here, we're going to be able to get anything from negative infinity all the way up to negative 1. But then we have this gap right in here, right between negative 1 and 1, where we have no value for it. That green value doesn't count. So just while we're looking at this real quick, that green here, I'm going to put it back in a minute because I want to leave it for you to look at. But that green is not there. So we basically have nothing in between there and there. And so we can say our range is negative infinity up to and including negative 1, union including 1 out to infinity. So just like that. Zeros, we have none. We have no zeros. This does not cross the x-axis at all. Our symmetry is even. So the y-axis is our axis of symmetry. It just mirror images across it. We have a period. If you'll notice, you almost are tempted to say the period is pi over 2 from here to here because that's where our u-shapes are, but we need it to fully repeat. So to get the fully repeat, we need an upward u, and we need an up u, and an upside down u, just like that. And so we're going to have a period of 2 pi, and our vertical asymptotes are going to be at just like they were back for this one, where we had this, which I probably should have put the plus or minus in here, but plus or minus these. But I'll just fix that real quick. N equals plus or minus 1, 3, 5, so on and so forth. But it's going to be the same thing. So I can essentially just take this right here. I can copy it, and we can put it right back over here for the vertical asymptotes here. Again, those odd values of pi over 2. Okay? And then we can go to the last one here, which is our cosecant graph. And the cosecant is going to be very similar to secant, but again, this time let's start with thinking about 1 over the sine of x. So if we can draw sine, we should be able to do this. Sine is 0 there, goes up to 1, through pi, down like that, and it goes like this. Okay? And so that's sine of x. And again, doing that same sort of thing, all the ones are going to stay ones. So negative ones and ones stay ones and negative ones. And so we'll have those. And then we're going to have our zeros here, here, here become asymptotes, right? So we're going to get our vertical asymptotes just from knowing that one. Okay. And then after that, it's the same shapes as we had before. As we get really close to 0, we're going to be really far from 0. So we're going to go like this. Because that's what happens when you take reciprocals. You take the reciprocal of a small number, you get a big number. You take the reciprocal of a big number, you get a small number. So we're going to get those U shapes again. Missed that one pretty well. We're going to get these U shapes just like that again. So again, you could ignore the green part in here. I'll put it back in a second, but you could ignore that green part. And that then would be your cosecant graph, okay? But I'll put the green parts back in just so you can see how I did it from that. Here, we're going to have a different set of domain and range. So for the domain, we can plug in every number. So all real numbers, except where we have those asymptotes. So except at 0, pi, 2 pi, except for in pi, so, well, let's not write that way yet, except for even multiples of pi, okay? And that's wherever sine of x equals 0. All the sine x 0 locations where we got those asymptotes. We're going to have a range, and again, notice we're below -1 and we're above +1. So we can't have anything in between. So the range, just like the previous one, is, parentheses, negative infinity to negative 1 inclusive, union 1 out to infinity. Just like that. And we're inclusive of the 1 and negative 1. Our zeros are occurring at even multiples of pi. So at even, multiples of pi. That's at 0, pi, 2 pi. Our symmetry here is odd, all right, about the origin. We can't just fold it over the y-axis and get it, but we can rotate it around that axis, and then this piece would rotate down and, directly go on top of that piece. So, about the origin, our period here is again 2 pi, because we have to go from here all the way to here, and over here in this part is where we'd have the right side up, the U shape again. So our period is going to be 2 pi. And then our vertical asymptotes, like we talked about, they're occurring at, really between the zeros. They're the zeros of sine, which occur at n pi's, where n is plus or minus 1, 2, 3, so on and so forth. All right, and that's just like over on this one right here, which was for our cotangent. Okay, and that's where our asymptotes occurred, because they're both occurring where sine of x equals 0. All right, well, that's the very last graph that we had to do here. So you really need to either have these graph shapes memorized, which you're welcome to do, or go through like I did, using the ideas of taking reciprocals of numbers and figure them out. If that's trouble for you, memorize them. But you need to know them. You need to be able to reproduce them and recognize them and shift them all around and things like that. The transformations are still going to apply to these, just like we've been doing the whole time. All right, that's all.